Tours. Today we're going to look at some factoring of degree 3 polynomials and maybe some degree 4, 5, and 6. All right, the first type of factoring is something called grouping. And you can do grouping of factoring by grouping when you see these conditions. First of all, it's got to be degree 3 because this is about degree 3 polynomials. And it can be done when there are 4 terms in the problem, 1, 2, 3, 4. And the ratio of the first 2 coefficients in the problem, so 1 to -5, equals the ratio of the last 2 coefficient and constant. That would be 4 to -20, which reduces to 1 to -5, right? If that happens, if you have a cubic function with 4 terms where the ratio of the first 2 coefficients equals the ratio of the last coefficient and constant, you can factor by grouping. Now here's what we say to do. I'm going to group the first 2 terms together. I'm going to group the last 2 terms together using parentheses. Now I'm going to GCF each parentheses. Okay, so what can I take out of this first parentheses right here? I think I can take it an x squared, right? That's the greatest common factor of those 2 terms. I would be left with an x minus 5. Now, to factor the second parentheses, I first have to factor out whatever this sign is from both these numbers. So I'm going to factor out a plus sign from both the 4x and the -20. Then I also have to factor out what number they have in common there. And you always have to take out a number, even if the number is 1. So out of 4 and 20, the greatest common factor is a 4. Now let's take a look. What will be left if I divide both of these numbers by +4? Well, positive 4x divided by positive 4 is x. And -20 divided by +4 would be -5. So I take the GCF out of each parentheses. And now notice, by doing this, I've created 2 terms. Remember, terms are things separated by adding and subtracting. Here's the first term, plus, here's my second term. If you notice, both of these terms have this identical parentheses in common, this x minus 5, right? So what I'm going to do now, in the second step, is I'm going to GCF. I'm going to take out the GCF, which is this common parentheses, the x minus 5, right? So if I take an x minus 5 away from each term, what's going to be left? Well, from this first term, if I take out this x minus 5, isn't the x squared going to be left? And in the second term, if I take the x minus 5 away, wouldn't there be a +4 left? Right? By doing this, as you can see, I have now factored that original cubic into 2 factors, x minus 5 and x squared plus 4. Okay? And that's factoring by grouping. Let's try it one more time. What if I had this problem? In example B, if I gave you, say, 2x cubed minus, say, 7x squared minus 2x plus 7. Well, let's see. It's definitely a cubic. There are 4 terms. And the ratio of the first 2 terms, 2 to -7, is that the same thing as the ratio of -2 to 7? Well, as you can see, this fraction, or this ratio of 2 to -7, that can be written as -2/7, right? And this fraction right here can be written also as the fraction as -2/7. Because remember, a ratio is a fraction. Would you agree these are equal? Moral of the story is, it doesn't matter who gets the negative between the first and the second number, right? So ultimately, I can use grouping on this. So let's do this. To solve this, or to factor this by grouping, I group the first 2 terms together, the last 2 terms together, and I take out my GCF. What do these 2 terms have in common? Well, they have an x squared. Now, if I take out an x squared, I'd be left with 2x minus 7 in the first parentheses. Now, in the second parentheses, I first have to factor out a negative. What do 2 and 7 have in common? Well, the only number they have in common is a 1, so I have to take out a -1. You always have to take out the sign, and you always have to take out a number, even if the number is 1. Okay? All right, so that being said, I take out a -1, what will be left? Well, let's see, -2x divided by -1 is +2x, and +7 divided by -1 is -7. Now, this is a nice mid-problem check. This parentheses here should be identical to this parentheses there. If they're not identical, then you're doing the problem wrong. Okay. Now, at this point, I collect the common parentheses from each term, leaving what's left inside. And again, what a lot of kids like to say is, you take what's inside the parentheses, write it first, and you take what's outside the parentheses and write it second. Now, wait a minute. If this problem said factor, well, that's implying that we need to factor completely. So if you take a look at this second parentheses, x squared minus 1, well, we learned how to factor that back in Algebra 1 and also in the quadratics chapter of this year. I know that I can break this parentheses down into two parentheses. And the same thing as x minus 1, x plus 1. Because isn't this the difference of two squares, right? So I can factor that completely. And I've factored, okay? Now I know what you're saying, well, why didn't you do that above in this problem? Well, if you say x squared plus 4, is that the difference of two squares? No, it's not, because that ain't a difference, that's a plus sign. So that one you can't factor like you factored x squared minus 1. And that's grouping. All right, now let's look at the second type of factoring of cubes. If I have something called the sum or difference of two cubes, here's what this says. If I have one number cubed plus or minus another number cubed, then I can factor him into two parentheses. I'm going to factor this into a short parenthesis and a long parenthesis. Now, again, it has to be a number cubed plus another number cubed or minus. Let's look at the plus example first. Okay, to factor this guy, the first thing I want to do to factor a cubed plus b cubed is whatever this number a that's being cubed is, I'm going to take a single one of him, and I'm going to put him in the first parentheses. And then whatever the second number being cubed is, I'm going to take a single one of these numbers and put him in the first parentheses. And then whatever this sign is in the middle here, I'm going to use the same sign here. So whatever these a cubed plus b cubed is, just take one of each number and keep making sure this sign agrees. If that's a plus sign, that has to be a plus sign. If that's a minus sign, that'll be a minus sign. We'll get into that in a second. Now, if you let it make sense, if I started with 3 a's and I take away 1 a, shouldn't there be an a squared left? So when I multiply this out, there has to be an a squared here. If I started with 3 b's and I took away 1 b, shouldn't there be a b squared at the end? Now here's the thing though. There has to be some middle term, because right now, if I multiply these out as is, like with a minus sign, if I multiply this back out, would you get back to the beginning? Well, let's find out. Well, let's see, what's a times a squared? That's a cubed. What's a times negative b squared? That's negative ab squared. What's b times a squared? Well, that's positive a squared b. And what's positive b times negative b squared? That would be, let's see, negative b cubed. Well, wait a minute. By doing this, do these two things combine? Can I actually add these? Well, no, because this exponent doesn't match this exponent, and that exponent doesn't match that exponent. So would you agree these do not cancel out? So wait a minute. That means I don't get back to this original problem. Well, if that's not the case, if you can't simply just put a squared minus b squared here with a minus sign, what do we do? Well, what you're going to notice is in this pattern, if I want, by multiplying, if I want to get back to just a cubed plus b cubed, I'm going to put in a third term in the middle here. And that third term will be the first number times the second number. But so because I want him to cancel out, if this is a plus sign, I'm going to put the opposite of that and put a minus sign there. All right? And again, this last number right here, since this was created by multiplying b times itself, or b squared, it's always going to be positive. So this is the pattern we use to factor a cubed plus b cubed. Now let's take a look at an example of where we use this. If I have something such as x cubed minus 8, I'm sorry, plus 8. This looks like the beginnings of this pattern of a cubed plus b cubed. I see an x cubed, that's like a cubed, but the 8, that is not. Well, if you think about it, is there a number that you could cube that would give you 8? Well, let's see, what's 1 times 1 times 1? That's 1. What's 2 times 2 times 2? Well, 2 times 2 is 4, 4 times 2 is 8. Oh, wait, isn't 8 the same thing as 2 cubed? So isn't x cubed plus 8 the same thing as x cubed plus 2 cubed? All right? Well, now this looks like the sum of two cubes. So for me to factor this, here's what I'm going to do. I'm going to take one of each one of these x's and 2's, and that's going to go in the first parentheses. All right? And again, this sign has to agree with this sign. Now, I'm going to use this short parentheses to create my long parentheses. I know I'm going to have 3 terms inside of here. To get these 3 terms, here's what you're going to multiply. You're first going to multiply the first number times itself. What's x times x? X squared. That must be the first term. You're then going to multiply the first term times the second term. What's x times 2? It's 2x. But again, because this factoring is the opposite of multiplying, if I were to multiply this back out again, I would need this middle term to cancel out. Well, the only way to cancel is for this positive sign to be the opposite, so a negative sign there. And to get this last term in the parentheses, I'm going to just multiply this last term again by itself. What's positive 2 times positive 2? Positive 4. And I factor. If you were to check your work by multiplying this out again, I should get back to x cubed plus 8. Let's do that quickly. If I have x times x squared, you get x cubed. X times negative 2x is negative 2x squared. X times 4 is positive 4x. Positive 2 times x squared is positive 2x squared. Positive 2 times negative 2x is negative 4x. And positive 2 times positive 4 is positive 8. Combining like terms, negative 2x squared and positive 2x squared, will those cancel? Positive 4x and negative 4x, will those cancel? And what am I left with? Oh, look at that, I'm left with x cubed plus 8. So I know that this factoring must be the right answer for this problem. Okay? All right. Let's try this one more time. But now let's do it from the standpoint of the difference. For the difference of cubes, it's going to be the same idea. But instead of having a cubed plus b cubed, this is going to be a cubed minus b cubed. Where you're going to follow the exact same pattern, where I take a short parentheses, I take one of each, I take an a and a b. If that's a minus sign, that has to be a minus sign. And I develop the second parentheses with 3 terms in it, using the first parentheses. I first multiply the first number times itself. A times a is a squared. I then multiply the first number times the second number. A times b is ab. But if that's a minus sign, I change that to a plus sign. It always has to be opposite, so they'll cancel when you multiply them back out. And then I multiply the last number, b times itself. Negative b times negative b is positive b squared. And that will be how you factor using the difference of cubes. So let me show you another example then, using the example the difference of cubes. Suppose I have, say, 8x cubed minus 27. Well, this one looks a lot different from the first problem we did. I see an x cubed, but 8 it doesn't look like it's a number being cubed, and neither does 27. Well, wait a minute. We just said that 8 is the same thing as 2 cubed. So isn't 8x cubed the same thing as 2 cubed x cubed? All right? Or isn't it just 2x cubed minus, well, if you think about 27, if 2 times 2 is 8, what's 3 times 3 times 3? Well, 3 times 3 is 9, and 9 times 3 is 27. Oh, isn't it the same thing as 3 cubed? So does it make sense that if I have 8x cubed minus 27, that's the same thing as this 2x in parentheses cubed minus 3 cubed? Well, now I've got something cubed minus something cubed. I can use this pattern of the difference of cubes. I take the first thing, I write it first, so 2x. I take the second term, I write it second, so 3. And I make the sign agree. Now I'm going to use this short parentheses to create the long parentheses. I multiply the first term by itself. 2x times 2x is 4x squared. I multiply the first term times the second term. 2x times negative 3x is negative 6x. But I got to change the sign. These have to be opposite, and they are now. And then I multiply the last guy, negative 3 times itself, you get positive 9. And I've now factored the difference of cubes. All right, guys, so that's it for now. We'll talk more about this next week.